Hello, I'm Roberto and I'm going to teach you physics. Okay, let me first clean the blackboard. Today my son asked me why, my son is 14 now, why the volume of a sphere is 4/3 of pi, the radius power 3. My son asked us very peculiar questions. Why the volume of the sphere is, I don't know really how to read it in English, 4/3 times pi times cubic r, probably, not sure. So this I could solve using something called integral calculus. Okay, integral calculus. I remember integral calculus. During my degree, I had to study lots of maths. I hated at the time. I really hated because they were so boring. And the best maths I ever had was when I was in my second year of secondary school. I was like 16, and my teacher was a physicist, and she taught us maths with a perspective that I really loved. Okay, but after that small period, small lapse of time, the 4 years in secondary school were horrible, and then I studied a lot of maths, especially during my first 2 years of physics. I had a very good professor in calculus, Rafael Crespo. If you see this, thank you, because you made me like maths for during the extent of your course. Okay, but except that, again, boring. Okay, but I think at least I kept something. So how do we calculate the volume of the sphere? The idea is to, I think we can do it. Today, the video I'm going today is one of the nightmares of a professor, which is being asked a question we don't know quite the answer, and being forced to, when we can't say, let me think about it and I'll answer tomorrow, because I have to explain other things, right? That's what we do when we don't know the answer. Interesting question. I would say, and you say something that is related to but let me think, and then you have time to think about the question, because this is what I do, what everybody does. But here I have to ask the question. So I think for the sphere, I found the answer, but based on a previous work that I couldn't solve. So as we can understand a sphere, like sphere is a ball, but it's not a ball, like pool ball, it is solid, like an orange. Okay, so in this case we are more appropriate like an onion, because what I'm considering is that is the sum of the layers of an onion. How many layers? So infinite layers, infinite number. So what I do is I make an infinite sum. So to do this, I remember that I have to, the volume is going to be this infinite sum is called integral. Okay, I hope you have previous ideas, but yeah, what I want to do is to solve this problem, not to explain really all the details. So for this, I have to multiply each surface by the thickness. Okay, so the surface is called exterior surface, each of the layers, times the thickness, and I'm going to change the thickness from 0, which is the center, to r, which is the radius of the sphere. So from 0 to r. The exterior surface of a sphere, just the other layers, are like an orange. What is orange? Only that surface inside, or if not orange, well, not that bright orange. Okay, like wanted to paint it an orange of black color, you would paint it in the outside, not in the inside. Yeah, so the exterior surface. The exterior surface, I remember, it was 4 pi r squared, or x squared, being x the size of the sphere. Okay. So if I substitute there, I have to. It will be 4 pi x squared dx. So the integral of 4 is going to be. Let me think. Because the derivative and the integral, they are one of the inverse of the other. So I don't quite remember. That's why it's so difficult. So it will be x squared. The derivative is going to be, let's put x3 is going to be 3x squared, but it's not that. So if I do, x power 3 divided by 3, when I do the derivative, okay, that will be the 3 will cancel, x2. Okay, so now that the integral is doing the other way around. So the 4 pi goes outside, 4 pi, and then it's the integral of x2 dx. The integral is the inverse of the derivative, and the derivative of x power 3 divided by 3 is just the 3 real. Well, yeah, okay. So that would be 4 pi, and then x power 3 divided by 3 between 0 and r. Yeah. So 0 will be nothing. So the result will be of this definite integral will be 4/3 pi r. Yeah. So good. I could solve it using the differential surface. Being this differential surface, one of the layers of the onion with a thickness which is differential, and then I make the integral, which is the infinite sum, changing the size of the onion layer between 0 and r, being r the radius of the sphere. So good, I have the volume. Good. But I'm based in the exterior surface of a sphere, which is 4 pi x squared, being x the radius of this. So I'm using, as you see, two different variables, one for the x for the integral, and another r for the constant value of the volume of the sphere. Okay. Now, I guess I told you, the worst nightmare, and I'm knowing the answer. The first part is clear, but I have to calculate the exterior surface of a sphere, and it must be 4 pi r squared, so being r the radius of the sphere. Okay, let's see. Now I have no idea. I've tried it before, and when I saw that I couldn't solve it, I decided to keep it for this class. Trying to solve a question, I don't know. I remember the first stuff. That was my first, I don't know, my first year.